2x power. So from here we can see that dy dx minus 1. Okay, dy dx minus 1 actually equal to 2e2x minus e2x power. Yeah. So the result actually is equal to e2x power. Okay. So here, because we can rewrite dy dx, we can write it by y plus 1. Okay, y plus 1. So here, so the first actually is we can rewrite it in this form: y plus 1 minus y equal to 0, and this is the same. Okay, we can rewrite it by in this form: or y plus 1 minus y equal to e2x power. Okay, 2x power. So here, now we can see this equation. Okay, this equation we have derivative, we have the function, yeah. And for this function, for this equation, okay, we have the derivative and we have the function. Okay. So here for equations in this kind, okay, we have the derivative, we have the function. So we call this kind of equation means the definition equations. Okay. So the definition equations. So here, what the definition equations means actually definition equations. Definition equation. So definition equation actually is an equation involve. A equation involve one or more derivatives of an unknown function. Okay, of an unknown function. So definition equation actually is an equation involve one or more derivatives of an unknown function. Okay, of an unknown function. So here we can see this equation. Okay, this equation we involve the derivative and we involve the function, and this function is the same. Okay, y here is the same. Okay, so involve the derivative, involve the function. Okay, so this is the definition equations. So for the definition equations, for example, we give some other examples. So this is the first, and the second, and now we can see for this function dy dx plus pxy equal to qx for this equation. Okay, so this equation actually we can rewrite it dy dx, we can rewrite y plus 1. Yeah. So here we can rewrite it by y plus 1 plus pxy equal to qx. So for this equation, okay, for this equation we involve the derivative. Yeah, we involve the derivative, we involve the function. So this is a definition equation. Okay, this is a definition equation. So for this and for example, for this equation, the for this equation, okay, here the second order derivative, the first order derivative, okay, the second order derivative, the first order derivative. So this equation is also a definition equation. Okay, is also a definition equation, and in this form. Okay, so dy dx plus px dy dx and plus qxy equal to some function rx. Okay, equal to some function rx. So for this equation, okay, for this equation it's the same. The the second order derivative, the first order derivative, okay? So the first order derivative, the second order derivative, this is an equation. So we call this equation is also a definition equation, okay? It's also a definition equation. So now, let's see in this equation, okay? In this equation, the highest order derivative actually is the first order derivative, yeah? And in this equation, okay, in this equation, okay, the highest derivative, okay, the highest order derivative actually is the second order derivative, okay. So this is the difference. This is the difference. So for the first one, okay, for the first one, we call it the first order derivative, the first order definition equation, and for the second here, because this we have the second order derivative. So we call this one, okay? We call this one equation, we call it the second order definition equation, okay? So here we have a definition of the order of definition equation, okay? So the order of the definition equation actually is defined like this: the order of definition. The order of a definition equation. The order of a definition equation actually is the order of the highest. The order of the highest derivative. The highest derivative that it contains, okay, that it contains the order of the highest derivative that it contains, okay. So this means the order of the definition equations. So here for the first one, we get the highest order, okay. The highest derivative actually is the first order derivative.
Love, I don't understand this two lines.
Yeah.
Yeah, from here, yeah.
The highest order actually is dy dx. The highest order is the first order derivative. So here, the order of this definition equation actually is 1. And for the second, the highest derivative actually is the second order derivative. Because here is the first order derivative, here is the second order derivative. So here in this equation, okay, the order of this equation actually is 2. Is 2.
So love, from where we get this expression?
From where? So here, this is the second order derivative.
Yes, love.
So the order of this equation is 2.
So minus 6 dy dx plus 8y. How do we get this?
This part actually is the second order derivative, yeah?
Yes, love.
So this is the first order derivative.
Yes.
So the highest order, the highest derivative here, the highest derivative actually is 2.
So love, 6, 8.
So this is not power, this is the second order derivative.
I know love, but that minus 6 dy dx.
So yeah, by minus 6 dy dx.
So 6. Why do you get 6?
Also, this is the example, okay? So I just for here, I give you an example. This is a definition equation, okay? This is an equation, okay? This equation we have. This is an equation, just an equation. Okay? So here 8 6. So of course here is 7 is also an equation. Okay, here is 8 is also an equation.
Thank you.
So now we can see, for example, for this example, so dy dx plus 7 dy dx plus 8 dy dx equal to 0. Okay, so for this one, okay, For this one is also this equation, okay? We have the derivative. The derivative here, this is the fourth order derivative. This is the third order derivative. This is the first order derivative. So actually here, for this one, okay, for this one, the order of this equation actually is what? Is 4, yeah? It's 4. So here, the order of the definition equation actually is the order of the highest derivative that is the content, okay? So this is the definition of this is the definition of definition equation. This is the definition of the order of definition equation, okay? So now we can see here, and now we introduce the definition of the solution, okay? So the solution of definition equations, solutions of definition equations So the solution of definition equations, for example, for this one, okay? For this one, y equal to ex. Y equal to ex, this function, okay? This function, okay? And this is the definition equation, yeah? This is the definition equation. So here, if we substitute this equation, okay, this function into this equation, we can see y equal to ex. So y prime actually is ex prime minus y equal to ex. So minus ex. So ex prime actually is ex, yeah? So ex minus ex actually is 0, yeah? It's 0. So here means that here means this function actually is a solution of this equation, okay? This function is a solution of this equation. So here we have that what the solution of definition equations actually is a function y equal to yx. A function y equal to yx is a solution. Is a solution of definition equation on an open interval. I. If the equation is satisfied identically, okay? Identically on I. When y and its derivative and its derivatives are substituted into the equation, okay, into the equation. So here, this is the definition of a solution of definition equations, okay. So a function y equal to yx is a solution of a definition equation on an open interval I, okay, on an open interval I. If the equation is satisfied identically, okay, identically on I, when y and its derivative are substituted into the equation, okay. So for example, for this example, y equal to e2x power, okay. So here, so for this example, y equal to e2x power, this function, okay. This function and this equation, y prime minus y equal to e2x, okay. So here, y equal to e2x power. This function, okay, which is a solution of this equation, okay, is a solution is a solution of this equation. So we can see here. So we need to see this function is a solution or not. So here we substitute this function into this equation, okay? So here we can see y prime, okay? Y prime actually is e2x prime, yeah? Y equal to e2x prime. So y prime actually is e2x prime, yeah? And minus y is e2x prime. So minus e2x prime. So now we need to compute it. So e2x prime actually is e2x prime times 2x prime, yeah? 2x prime is 2, so times 2 and minus e2x prime. So here is e2x times 2 minus e2x actually equal to what? Equal to e2x, yeah? So equal to e2x. So here we can see here is e2x, here is e2x. So here means that this function, okay, we substitute this function into this equation. We can see that the equation is satisfied identically, yeah? Yes. So here means y equal to e2x is a solution of this equation, okay? Yes. So this is the first. So for the second, now we can see for this function y equal to c times ex power c is a constant plus e2x power, okay? Y equal to cex plus e2x power, okay? This is a solution of y prime minus y equal to e2x power or not. So now we need to see this function, okay? This function here c is a constant. Y equal to c ex power plus e2x power. This function is a solution of this equation or not. So here we need to see y prime minus y. So here y equal to this function. So y prime actually is cex plus e2x the whole prime, yeah? This prime minus cex power plus e2x power. So here we need to compute this, okay? So the first here, this prime equal to the first term prime, yeah? So the first here, cex prime is what? Cex, yeah? Because c is a constant, yeah? Constant, so it's ex prime actually is ex, and plus e2x, 2x power prime. 2e2x, yeah? So this is the second prime. So minus cex power and minus e2x power. So here we can see here is cex, here is cex. So these two terms cancel, okay? And here is 2e2x, here is 1e2x. So the result actually is e2x power, yeah? So from here we can see here is e2x power, here is e2x power. So here we can see this function actually. This function is a solution of this equation, yeah? Yes. So here we have the conclusion that y equal to cex plus e2x power, okay? This is a solution. It's a solution of the equation y prime minus y equal to e2x power. E2x power. Yeah.
I have a question.
What?
Where did the 2 go?
This 2 go.
Yeah.
The 2e2x power minus e2x power. So here you can take out the e2x. So you can take out the e2x power. Here is 2 minus 1. Here 2e2x minus e2x. So 2 minus 1, so it's 1 times e to x power. So here now we can see for this equation, okay? So now we can see this equation, y equal to e to x power is a solution of this equation, and y equal to cex plus e to x is also a solution of this equation. Now we can see these two equations actually the same, yeah? But now, so here this is a solution, this is also a solution. Actually, this solution, okay? This solution. Here C is any constant, okay? C is any constant. So here, when C equal to 0, this solution actually is this solution, yeah? So this, when C equal to 0, okay? When C equal to 0, this solution actually is this solution. So here, this solution actually, we have some difference, okay? In mathematics, we call this solution actually a general solution, okay? General solution means this solution actually represent the all solution, okay? Represent all solution of this equation. So here we have a definition is the general solution, okay? General solution. So here we have the definition of general solution. General solution of a differential equation. So here I'm giving interval I. So a solution of a differential equation from which all solutions on I can be drawn. Can be drawn by substituting wheels for arbitrary constant. So here general solution, okay? General solution of a differential equation actually is on a given interval I. A solution of a differential equation from which all solutions on I can be drawn by substituting values of arbitrary constant. So here we can see for this one, actually is a general solution, because here we can see this solution can be drawn by C equal to 0. Yeah, can be drawn by C equal to 0, and actually here, when C equal to 1, C equal to 2, it's also a solution of this equation. So here, general solution, okay, actually you can understand it here, you can understand it as a general form, okay? General form. A general form of all solution, okay? Of all solution. So a general form, okay, a general form of all solution. This actually is a general solution, okay. So here means, for example, for this solution, okay? This solution is a solution of this equation. So here means the solution of this equation, is like this, okay, like this. Y equal to CEX plus E2x power, okay, E2x power. So this is the general solution. So now, next we will introduce the first order. So the first order initial value problem. Okay. So the first order. I will introduce the first order linear differential equation. Okay. The first order linear differential equation. The first order differential equations. So here. The first order linear differential equation actually is in this form, okay? In this form, dy dx plus pxy equal to qx. So here px and qx are continuous, okay? Px, qx, these two functions is continuous, okay? So here, dy dx plus pxy equal to qx. So here this is the first order, okay? The first order because the highest derivative in this equation actually is dy dx, yeah?
Yes.
So this means the first order, okay?
Yes.
So the first order here is because this is the first order, okay? So here the second because the differential equation, because this is the equation involve derivative. So this is the differential equations. So what about linear? So linear, okay? So linear actually is this part. Because we can see, so what about linear mean? Okay, linear mean, okay, linear mean. So linear actually is this part. This part means linear because we can see dy1 plus y2, okay? Dx, here y1 is a function, y2 is another function, plus px y1 y plus y2, okay? So here actually equal to what? Here actually equal to dy1 dx plus px y1, okay, this is the first part. The second part is dy2 dx plus px y2, okay. So here we can see if here is y1 plus y2, okay. y1 plus y2. This part is linear, okay. Here means linear. So actually, how to explain linear? Linear actually is. So this is linear, okay, this is linear. So now we can see which one is not linear. For example, for this example, okay, for this example here, for this is linear. Now we can see for this dy dx plus px. If here is y square, okay. If here is y square equal to qx. Now for this one, okay, the difference is here is y square, here is y, okay, and this one we call it linear. linear, but this one actually is non-linear. It's non-linear. Why? Because we can see dy here is y1 plus y2 dy1 plus y2 dx plus px y1 plus y2 square. This one, okay, this one, and dy1 dx plus px y1 square plus dy2x plus px y2 square. Okay, this one not equal to this one. Okay, the left hand side not equal to the right hand side. Okay, because here we have a square here. Here square here. So this the first term actually equal to dy1 dx plus dy2 dx. Yeah. The first term actually equal to dy1 dx plus dy2 dx. Yeah. But here y1 plus y2 square. This part, okay, this part actually is px y1 square plus px y2 square plus px times 2y1 y2. Yeah. So here we have this term. Okay. So here this one do not equal to the right hand side. Okay. So here this term. Okay. This term is non-linear. So here this actually is the first order non-linear. First order non-linear differential equation. So first order nonlinear differential equation, okay? Because here is y square, this y square is nonlinear, okay? It's nonlinear. So here, so I think that it's easy to see. For example, for y cube, okay? Y cube actually is also nonlinear because y1 plus y2 cube, this not equal to y1 cube plus y2 cube, okay? So this is also nonlinear. For example, here is y to the fourth power is also nonlinear, okay? But for here y actually is linear because y1 plus y2, y1's power actually is y1 plus y2. So this is linear, okay? So this is linear. So here I think that is so now we will introduce to study this first order linear differential equation. Okay, first order linear differential equation. The first case is we can px equal to 0. Okay. So now we study this linear this first order linear equation, differential equation. So we study two cases. The first case is px equal to 0. So when px equal to 0, actually this equation actually is dy dx equal to qx. Yeah. Dy dx because px equal to 0. So this equation actually is dy dx equal to qx. Yeah. So now, what's the solution of this equation? So dy dx means we need to find a function such that the derivative of the function equal to qx. So the function actually is what? Is the antiderivative of qx. Yeah. So here the solution of this equation actually is y equal to the antiderivative of qx. qx. So for example, for this example here, dy dx equal to x cubed. Okay, so dy dx equal to x cubed. So y equal to what?
X about 4 over 4.
So here dy dx equal to x cubed. So y actually is the antiderivative of x cubed. Yeah. So here y equal to the antiderivative of x cubed. So dx. So this equal to what? So this is equal to 1 by 4 x to the 4th power plus a constant c. Yeah. So here means that for this equation, okay. So for this equation, the general solution of this equation actually is 1 by 4 x to the 4th power plus c. Okay. So here this is the simple case. Okay. The simple case px equal to 0. So what about px not equal to 0? So when px not equal to 0, okay? When px not equal to 0, so now we need to find the general solution of this equation. The general solution of this equation. So here, now we need to find the general solution of this equation px not equal to 0. So listen to me, okay? I will introduce a method. To find this general solution. Okay. So here, for this one, we let mu equal to e to the power. Here is the antiderivative of px. The antiderivative of px. Okay. So here we introduce this factor. Okay. This factor mu. Mu is e to the power. Okay. Mu is e to the power px. The antiderivative of px. So actually this mu, because this is a function of x, yeah. So of course mu is also a function of x. So now we have the derivative of mu actually is what? So here d mu dx actually equal to what? So here for this one, we use the u substitution. We let u equal to this antiderivative. So here actually is e to the u power, u equal to what? U equal to the antiderivative of px. Yeah? The antiderivative of px. So here du dx. Actually we use the chain rule, actually equal to what? d mu du times du dx. Yeah? d mu du. So d mu du. Mu equal to e to the u power. So d mu du actually is what? It's e to the u power. Yeah? E to the u power. So du dx. U equal to the antiderivative of px. So du dx is what? Px. Yeah? So here equal to e to the u power times px. So the result, we replace u by this antiderivative. So here this is equal to px times e to the power the antiderivative of px dx. So here now we can see this. Okay, here this part actually is mu. Yeah, it's mu. So here actually is px times mu. Yeah, times mu. So here means d mu dx. Okay, d mu dx is equal to px times mu. So so for this equation, we times mu on both sides. Okay. So for this equation, dy dx plus pxy equal to qx. For this equation, okay, dy dx plus pxy equal to qx. Now we times mu on both sides. Okay, we times mu on both sides. So here actually we have mu dy dx plus px mu times 1, okay, times 1 equal to mu times qx, yeah?
Yes.
We times mu on both sides. So now here we can see px mu, okay? Px mu actually is what? Px mu actually is d mu dx, yeah? So here we replace px mu by d mu dx. So here actually is mu dy dx plus d mu dx times 1 equal to mu qx. Yeah? We replace, because this part, okay, this part is px mu. And we, from this step, we know that d mu dx is equal to px times mu. So we replace px mu by d mu dx. So here we rewrite this equation actually is mu dy dx plus d mu dx times 1 equal to mu dqx. So now from you can see the left hand side actually is what? The left hand side actually is what? So here's mu times y prime plus mu prime times 1. Here is mu. Here is y prime. Mu times y prime plus mu prime times 1. So the left hand side actually is what? So actually we know that f times g prime equal to f prime times g plus f times g prime. Yeah. So here the left hand side actually is what? Actually is so the left hand side actually is the derivative of what? Mu times y dx. Yeah? The left hand side actually is mu times y d mu y dx. Yeah? So equal to what? Equal to mu qx. Yeah? So from here we have this equation actually is this equation. So so this equation. So for this equation we can see the derivative of this function equal to this function. So this function actually is the antiderivative of this function, yeah? Here, the left hand side, so this equation tells us that the derivative of mu y actually is mu q. So here means that mu y actually is an antiderivative of mu q, yeah? So here from here we have what? So from here we have mu y actually equal to the antiderivative, okay? So the antiderivative of mu q dx. So from here we have y equal to what? So we divided the mu on both sides, okay? So we divided the mu on both sides. So here we have y equal to what? So y equal to 1 by mu. So y equal to 1 by mu. Okay, 1 by mu times the antiderivative of mu qx dx. Okay. So here, this is the general solution of this equation. Okay. This is the general solution of this equation. Here mu is what? Here mu is e to the power antiderivative of px. So of course you can remember this formula. Okay. You can remember this formula.
Yes.
This is the first way. Okay. This is the first way. The first way is for this equation you can remember the formula, okay? You can remember the solution in this formula, okay? The second way is I hope that you can remember the close signs, okay? The close signs. So this is the solution, okay? This is the solution, the general solution. So now we have a break, 10 minutes. So attendance, okay?